Evening, everyone. I'd like to talk to you about the regression dynamic scanning. In Gazprombank, we call it Cybersecurity Regression Automatic Testing System. Don't be scared with this title. And during my talk, I'd like to coin the term RDAST because there are multiple dynamic analysis acronyms such DAST, EAST, statistical analysis, and so on. And for the first time ever, Gazprombank coined the regression testing, and we decided to use the RDAST acronym. I'm head of the security analysis department with Gazprombank. I'd like to introduce to you my colleagues, my team, who provide support to automatic testing and develop additional modules. Basically, my team and I were responsible for integrating this concept. So why do we need regression automatic testing? Because, you know, you can test software, while regression testing means that we need to check all the defects that we detected before, all the new defects that emerged, their correction, as well as the resilience of the system before it reaches the production stage. RDAST lived up to its expectations during the CI/CD process. We all know that during this process we design, develop, test, deploy, and review a product before a feature reaches the production stage. In Gazprombank, we call every new development a feature. Therefore, we need to test various features on a constant basis. And since it's a continuous task, it should be automated, which is only logical. And that allowed us to ensure coverage, a greater coverage of the app resilience. Our scanning is directed. I'll give you more details on the difference between the directed scanning and the usual scanning. And the time to market is not affected because the speed is higher. What exactly do we test? Because, you know, security analysis is done with regards to web apps or mobile apps. Oftentimes, all the mobile apps, especially in fintech, use microservices. In other words, the backend features lots of services. And when we execute one or other scenario, let's say it's taking out a mortgage or taking out a credit card, we see a sequence of requests going to the server. And we use HTTP protocols. And it's well known there is an AB function and parameters in this function. Cookies, various headings, and the data of the request per se. And it's quite obvious that there are multiple places to test. In the headings, we check the values, the parameters, and then we test JSON or XML format data if we use the SWOT protocol. Or it could be a blank text with values and parameters. It's on a case-by-case basis, depending on the service used and the way it was designed by the developers. In order to ensure AppSec, we need to constantly carry out dynamic testing. How do we do that? We split it into two entities. I mean, the dynamic analysis is split into two parts. The first one is the common black box part, and we try to identify potential vulnerabilities. We integrate various tools into CI/CD process under the DevSecOps. And the second part includes fuzzing. That's the most effective way to detect vulnerabilities, as far as I know. Testing the business logic, and not all dynamic testing systems and tools available in the market can actually test the vulnerabilities specific for the business logic. And as part of the regression, we carry out targeted dynamic scanning by using specific temples that we get from various Swagger schemes under the service specification, or with the help of OpenAPI templates. It took us a long time to select the relevant tool because, tool selection is probably the most important issue. We started analyzing the market as well as open source solutions. We took a look at the add-ons of the Burp Suite, OWASP Zap, another product that we analyzed. There are lots of automation scripts, and ultimately we said we should not go there. We could have automated everything with the help of Python by writing a bunch of scripts, then formalize it through requests, get responses, and analyze them. And then it shouldn't come as a surprise, but we learned that there is such a wonderful tool as Nuclei by Project Discovery. It's an open source, free of charge tool that can discharge all the tasks I mentioned before. So how do we use it for the sake of regression testing? We deployed a virtual environment, and this is where we run this tool. We also developed a script that runs it from the command line with certain parameters, and then we send the so-called template. During the scanning, we launch in sequence several scripts. The configuration script is used depending on the system, which are different, and there are specifics in each one. If we did just simple DAST and we would just press the scan button, the scanning would have been done, but the coverage wouldn't have been comprehensive. And don't forget about the system authentication. Systems are different. Some systems run on basic, some use specific tokens, and all the other parameters have to be taken into account. So to collect the results, we run the results processing script. This is a more detailed diagram showing the flow. OutSpy script is for collecting tokens.
Очень тонко каждой системе для того, чтобы авторизация была правильной. Потому что есть еще также проблема, которая заключается в том, что где-то токен живет минуту, где-то он живет...
In some systems, a token lasts for a minute, in some for 5 minutes, for an hour, or for a day. And the Ekron is used to re-authenticate within the system to run the business scenario. The scanning templates allow us to drop payloads, and we're talking about a huge number of various payloads such as XSX, SQL injections, and others. Business as usual, it's part of an intruder in the Verosuit. then we parse the results that are then converted into a syntax highlighted format, which is easy to read. We wrote our own script for dynamic testing, and for every scenario we have its own template. There could be several requests as part of a business scenario, and it is automated by the EML template. To be able to detect various vulnerabilities, we use the so-called detectors or matchers that can be described with regular expressions. This slide shows the response 200 status when everything seems to be fine, and the response time is over 1 second. That means that it should set you thinking that it could be an SQL type injection or not. Well, it could be investigated on a case-by-case basis, and the extractors allow us to get the identifiers from requests 1, 2, 3, for instance, and identification data on a mortgage or a credit card, so that the scenario keeps on running. Because when you execute requests 1 and 2, everything is fine, but during request 3, this token is no longer valid. Therefore, follow-up scanning is not going to be accurate, and we'll have to start everything from the scratch. Unfortunately, there are no commercial off-the-shelf solutions that would allow you to start a risk scan from the point you stopped at, because all the systems are alike, the backend is different, and it's difficult to come up with a common denominator. But we managed to use this tool to this effect. This is a standard request and response. We put all of them into a big file in sequence.
Запускаем наш парсер, который
Then we'll launch our parser,
все запросы-ответы и подсвечивает различные
which highlights the various defects
в веб-интерфейсе.
That we can visualize in a web interface.
Тема рабочая.
Well, overall, it works. It's effective. The run scripts and the code will be uploaded to GitHub and to our Telegram channel. So download it. Stay tuned. And if you have any questions, I'll be happy to take them. I'll be right by this conference hall for some time. So let's discuss your SSD processes and the way you automate dynamic testing in your companies. I would be interested in learning more details about that. Thank you so much for your attention, and see ya.